So looking at example 2, we're going to do the same thing, except in this case, we need to factor the denominator first. So I'm going to rewrite this fraction as x minus 7. And the factors of the denominator are going to be two numbers that multiply to negative 3 and add to negative 2. So it's going to be x minus 3, x plus 1. And then now we can set up our partial fractions. So I'm going to have our x plus 1 and x minus 3. So setting this up, I'm going to set up my a coefficient. So a over, we're going to have x minus 3 plus b over x plus 1. And then cross multiplying this, we get ax plus a plus bx minus 3b, and that's going to be equal to x minus 7. Okay, so we're going to group our terms, so we end up with ax and bx, so we get a plus bx plus the constants a minus 3b, and that's going to be equal to 1x minus 7. Okay, so I'm just going to highlight that that's 1x. Just make sure that looks a little bit neater. So we're going to end up with 1x minus 7. And then we can group these terms. So we end up with the a plus b equaling the 1. We know that the a minus 3b is going to be equal to negative 7. So I'm going to set up my two equations. A plus b is equal to 1. My second equation is going to be a minus 3b is equal to negative 7. Okay, and then I'm going to solve for a in this case. A is equal to negative 7 plus 3b. And then I'm going to replace the a in the green equation with 3b minus 7. So I'm just going to switch that around. And then plus b equals 1. Okay, so what I've done is I've replaced this a with the a that I solved for in yellow. Solving this, then I end up with 4b. I'm going to add 7 to both sides, so I get equals 8. So b is equal to 2. Okay, so I've solved for b. I'm going to then solve for a by plugging it back into one of these equations. So in this case, I'm going to get a equals negative 7 plus 3 times b, which is 2. And that came from the solved b. And so being able to solve for a is equal to negative 7 plus 6 is going to be negative 1. So now I've solved for a. I now have my partial fraction, so now I can try integrating this. So when I rewrite the integral for this, with the a, I end up with the negative 1. I'm just going to put that to the outside, over x minus 3 plus, for the b, I ended up with 2. So I end up with 2 over x plus 1. And integrating these terms then, I end up with negative log x minus 3. So this is going to be a negative log, so it should end up in the denominator, plus my positive log of x plus 2. So this term will end up in the numerator of a log expression. And then don't forget the plus c. Okay, so rewriting this with one log, I'm going to end up with log x plus 1 squared. And because it's a negative exponent or negative log, we're going to end up with x minus 3 in the denominator plus c. Okay, so I went from one that I couldn't anti-differentiate because there's no substitution available here. We can't use power rule. There's no product rule that would work in this case. So we had to use our partial fractions to be able to solve this. Now, when we do partial fractions, it is really important that we have the numerator a smaller power than the denominator. Okay, so in order to apply partial fractions, we have to divide first if the numerator in this case is the same power. So we're going to do our division. So I'm going to do my long division here. So I end up with x squared plus 7x plus 10, my divisor, into my numerator. So x squared plus 7x plus 4, it goes in there once. We end up with a remainder of negative 6. So then we can rewrite this in terms of it's the quotient 1. So 1 plus the remainder over the denominator. And I'm going to factor the denominator while we're here. So it's x plus 5, x plus 2. So 2 times 5 is equal to 10. 2 plus 5 is equal to 7x. So this is my new fraction. I'm going to integrate both of these. And in the case of that right-hand one, this is a partial fraction. So we're going to have to split this into partial fractions to do that one. I'm going to anti-differentiate the 1 dx, so that just becomes x plus, and we're going to set up our partial fractions for this one. So we're going to end up with a over x plus 5 plus the b over the x plus 2. And then we're going to cross multiply and set up our partial fractions, solve for partial fractions here. So ax plus 5a plus bx plus 5b. Oops, I made a mistake here. This should have been plus 2 in blue. So this should have been 2a. So bx plus 5b. And that's going to be equal to our negative 6 that we had in the numerator here. There's our negative 6. There's our negative 6. So grouping our terms again, we're going to end up with a plus bx plus 2a plus 5b is equal to negative 6. We know that the constant is equal to negative 6. The a plus b is equal to 0 because there's no x term on the right-hand side. So we're going to have a plus b equals 0, or a equals negative b. And then our second equation is going to be 2a plus 5b equals negative 6. I'm going to replace my b with a with a negative b, so I end up with negative 2b. And I'll write that in green. Negative 2b plus 5b is equal to negative 6. So we end up with 3b equals negative 6. B works out to be negative 2. Okay, so there's a b value that makes the a value equal to positive 2. Okay, so once we solved our partial fractions, we can then use that to set up our integral. So we're going to end up with the integral of 2 over x plus 5 plus, we're going to end up with the b is going to be, so I'm going to write that as negative 2. In this case, one I factored out the 2, the other one I left the 2 in. So I've kind of switched it up, but that's okay. You can put that 2 wherever you want. Dx, so working this out, x has already been anti-differentiated. This becomes 2 the degree 1, so we're going to use our log function, x plus 5 minus 2 log x plus 2 plus c, and then we can combine these together. We end up with log x plus 5 squared on top of this minus, so it's going to end up in the denominator, x plus 2, and that 2 becomes a power square inside the log. Okay, so there is our partial fraction solution. We had to first do long division and work out get the numerator degree smaller than the denominator. Once we do that, we can apply the partial fraction. Okay, when we do that, we left over this quotient, which we have to integrate as well.